This is a combined lesson on zero exponents and negative exponents. They're used a lot, and negative exponents are especially tricky, so please make sure you try and get a strong understanding of this. Alright, the zero exponent. Let's first start with some examples. For instance, what's 6 divided by 6? Hopefully you're thinking 1. What's negative 2 divided by negative 2? Hopefully again you're thinking of 1. Well, if we use the laws of exponents, what is x cubed divided by x cubed? So we just did a lesson on this, dividing exponents, and we kept the base and subtracted the exponents. Well, 3 minus 3 would be x to the 0th power. But we also said when we divided the same number by itself, we got 1 and we got 1. So what should x cubed divided by x cubed equal? If it equals x to the 0th, that should also equal 1 because it's the same thing in the numerator as it is on the denominator. Therefore, what does any power of 0 have to equal? It has to equal 1. So our rule, our law of the zero exponent is for any non-zero number, this means that we cannot take 0 to the 0th power. So for any non-zero number a, the rule is a to the 0th power equals 1. So let's look at some examples. First of all, we have negative 1,245 to the 0th power. It doesn't matter what it is, but anything to the 0th power equals 1. So same thing, 12m to the 8th n to the 7th divided by 8m to the 5th n to the 10th. Sure, we could simplify the inside, but no matter what, it's going to be taken to the power of 0, and that equals 1. If I had math to the 0th power, still equals 1. However, let's look at these two examples. We have x to the 0th, y to the 3rd over y squared. Although everything that's to the 0th power equals 1, you have to be careful. This power of 0 only goes to what's directly in front of it, and that's the x. There is no 0th power to these two. It is just to the x. So if we simplify this, x to the 0th is 1 times y to the 3rd over y squared. Well, y to the 3rd divided by y squared is y to the 3 minus 2, and 3 minus 2 is 1, so this is going to equal y to the 1st power. So be very careful. We have a tendency to want to put the power of 0 to everything. Take another look at the next example. We have 2 times x to the 0th power. This 0 power only goes for what's directly in front of it, which is the x. It would have to have parentheses around 2x for the 0th power to go to both. So this is 2 times x to the 0th. Well, x to the 0th equals 1, so 2 times 1, which equals 2. I repeat, it would have to have parentheses around the 2x for everything to be taken to the power of 0 and for it to equal 1. There is a very big difference between these two, and a lot of students make these mistakes, so be careful. Alright, next we have negative exponents. There's really two rules to remember. For any non-zero number a and any integer n, a to the negative n is the reciprocal, it's a key word right there, reciprocal of a to the n. In addition, the reciprocal of a to the n is a to the negative n. So let's look at the rule. For any non-zero number a and any integer n, a to the negative n is the reciprocal of a to the n. Reciprocal meaning the reversed fraction. So if it's on top, it's moving to the bottom. If it's in the numerator, it moves to the denominator. But the same thing, if I have 1 over a to the negative n, that's the reciprocal. It's going to move to the top. So you just have to remember fractions. If it's not written as a fraction, assume it's on top, and it's going to move to the bottom and become positive exponent. If it's on the bottom, to get rid of the negative exponent, we're going to move it to the top. We're flipping it. So looking at some examples, we have 5 to the negative second. This is like 5 to the negative second over 1. We hate negative exponents, never want them, so we have to simplify it. We're going to keep the base the same and keep the exponent the same, but we're going to flip it. We're going to put it in the denominator and make the exponent positive. Well then, 1 over 5 squared is 25, so that's our final answer. Looking at the same thing, we have 1 over m to the negative third. We don't like negative exponents, so to get rid of that, we have to flip it. Since it's on the bottom, the m to the negative third is going to move to the top and become positive. So it's going to equal m to the third. Finally, we have 4 times x to the negative seventh. Again, just like that example with the power of 0, people have a natural tendency to want to take 4x to the power of negative 7. But the exponent only applies to what's directly in front of it. So this is like 4 times x to the negative 7th. So to get rid of the negative exponent, we have to put it into the denominator. But are we moving the 4? Hopefully you said no. So it's kind of like 4 over 1 times x to the negative 7th over 1. And we're going to flip only this one right here. And we're left with 4 over x to the positive 7. Okay, I want you to pause the video and try these two on your own. Just quickly for the first one, remember, you're only moving the ones with negative exponents, and if they're on the top, you're moving them to the bottom, and if they're on the bottom, you're moving to the top. So pause the video, try these two examples. Alright, hopefully you've tried them, and you saw, well, I have b to the negative third, I don't like the negative exponent, so if I have my division symbol, I'm moving b to the negative third to the bottom. So I have b to the third. C squared, that's positive, so we're not doing anything with it. It's going to stay on top. And then we have d to the negative fifth in the denominator. Again, we don't like negative exponents, and because it's on the bottom, we're going to flip it and move it to the top. So this is our final answer. C squared d to the fifth divided by b to the third. Looking at the second example, we have p to the negative 8 divided by p to the third. There's two ways we can look at this problem. We can use our laws of exponents and subtract negative 8 minus 3. Well, use your calculator. Negative 8 minus 3 is the same thing as negative 8 plus negative 3, which is going to give us p to the negative 11th. Because we don't like negative exponents, we're going to put it on the bottom and get 1 over p to the 11th. The other way we can look at this problem is get rid of the negative exponent immediately. We don't like p to the negative 8, so we're going to put that on the bottom. P to the third, it's a positive exponent, so it's going to stay on the bottom with the p to the 8th. And then we have our 1 over p to the, since we're multiplying, we're going to keep the base, add the exponents, and we get 1 over p to the 11th. So you can see we get the same answer either way we do it. So it doesn't matter which way we do it as long as we do it correctly. Alright, again, pause the video, try these two problems on your own. Alright, so just like the example with p, there's two ways we could have looked at this. We could have moved 2 squared would stay on top and move the 2 to the negative third to the top as well. and would have gotten keep the base, add the exponents, 2 to the 5th. The other way we could have looked at it is 2 to the 2nd minus negative 3. Well, that equals 2 to the 2 plus 3, so it's 2 to the 5th. Either way, you would have gotten the right answer. Looking at the second example, we have x to the 4th, y to the 0th over x to the negative 2nd. Let's take it step by step. First of all, x to the 4th times y to the 0th. Well, anything to the 0th power is 1, so y to the 0th is 1, over x to the negative 2nd. So now we're left with x to the 4th over x to the negative 2nd. Again, you can do it either way, but basically we're going to have x to the 4th times x to the 2nd, and that's going to equal x to the 6th. If you got these two examples right, I think you're understanding it. Alright, let's look at one more example, and this one's particularly tough, so I want you to pause the video and try your best to solve it again. Alright, using our laws of exponents, we're going to first distribute this exponent of 2 to each term on the inside. So I'm going to have 3 to the 2nd times s to the 2nd times t to the 2nd times u to the negative 4th divided by s to the negative 1st times t to the 2nd times u to the 7th. Now I personally like to group all of my numbers and similar variables together. So I'm going to have 3 squared on top, 1 on the bottom together. I'm going to have s squared on top, s to the negative 1st on the bottom together. Then I'm going to have t squared over t squared together. And finally, u to the negative 4th over u to the 7th together. Now let's simplify each of the insides. We have 3 squared over 1, so that's 9 over 1, times s to the 2nd divided by s to the negative 1st. Well, that s to the negative 1st is going to move to the top, and we're going to have s to the 3rd over 1. T to the 2nd divided by t to the 2nd is t to the 0th over 1, which we know is going to equal 1. And then u to the negative 4th divided by u to the 7th. I'm going to bring that negative 4th to the bottom, and I'm going to have u to the 4 plus 7. If we put this all together, our final answer is going to be 9. So we have our 9. Our s to the 3rd, t to the 0th, but that equals 1 times 1 is 1, all over 1 times 1 times 1 times u to the 4 plus 7, which is 11. So our final answer is 9s to the 3rd divided by u to the 11th. If you got this and were able to solve this problem, then I think you understand this. If you didn't, that's okay. It's hard, but practice makes perfect, so keep trying.